Next question is question number 2.55. Emission transitions in the paschen series end at orbit n is equal to 3 and start from the orbit n. So here I am going to consider n is equal to 3 as n1. Okay, and it will start from the orbit n, which means n2 can be 4, 5, 6 and so on. Now, and can be represented as nu, which is the frequency 3.2910 raised to power 15 hertz, 1 by 3 square minus 1 by n square. Calculate the value of n if the transition observed is 1285 nanometer. Find the region of the spectrum. So first what we are going to do is let's write down what is given to us. We are given with the lambda value, which is 1285 nanometer. So we can write that lambda is 1285 nanometer. This 1285 nanometer can be converted to meters. So that can be 1285 into 10 to the power minus 9 meter. But we need some significant figures here. So what we will do is 1.825. So what we did 1, 2, 3. So that will make it 10 to the power 3 into 10 to the power minus 9. When we simplify this, you will get this as 1.285 into 10 to the power minus 6 meter. So this is going to be the wavelength that we are going to use. Now wavelength is given to us. We should know what is the frequency for this particular wavelength. So frequency, simple formula we know, c by lambda. C is velocity of light, so that's going to be 3 into 10 to the power 8 meter per second divided by lambda is 1.285 into 10 to the power minus 6 meter. Meter and meter will get cancelled. When you divide both of this, you will get 2.33 into 10 to the power. Minus 6 goes up, it will become plus 6. So this will become 10 to the power 14 seconds inverse. So this is going to be one frequency. Now what we are going to do is we are going to use this particular formula and we are going to calculate what is the n value for it. So here we are going to repeat the same formula here. So nu is equal to 3.29 into 10 to the power 15. Hertz can also be written as seconds inverse into 1 by 3 square minus 1 by n square. Now nu value we already have here. So left hand side I am going to equate it. That will be 2.33 into 10 to the power 14 seconds inverse equals 3.29 10 to the power 15 seconds inverse. 1 by 3 square will become 1 by 9 minus 1 by n square. Now here seconds and seconds can get cancelled because they are of the same unit. Now I will take this entire equation on the other side. So this will become in the denominator. So here I'll write that 1 by 9 minus 1 by n square equals 2.33 into 10 to the power 14 divided by 3.29 into 10 to the power 15. Let's divide both of this. So you will get 1 by 9 minus 1 by n square equals 2.33 divided by 3.29 will be 0.7082 into minus 15 will go up. So it will become 10 to the power minus 1. So now this will become 1 by 9 minus 1 by n square equals 0.0782 when you do into minus 1. Now what I'll do, I'll take the number on the right hand side. So this will become 1 by n square equals 0.0708 in minus 1 by 9. I'll take simple LCM method here. So this will become minus 1 by n square. 9 into this will give you 0.6372 minus 1 divided by 9. I took LCM of this. Now minus 1 by 9 square, n square is equal to, when I divide both of this, I will get minus 0.04031. I put minus sign here because when you minus it, you get a negative sign. So this is going to be the value after you divide it. Now n square is what you're going to find out. So n square is equal to 1 by 0.04031. Negative and negative will both get cancelled. Now when you take this, here n square is equal to 24.80. But n square is not asked. We want to find out what is the n value. So you can write that n is equal to root of 24.80. Therefore, n is 4.98, or approximately it can be 5. So when n is equal to 5, it is basically the Balmer series, because 3 to 5 is, this will be observed in the IR region. They only told to find what is the region, so you can say this is going to be the IR region. That you will find out when you put down the hydrogen spectrum and you see what is the starting and what is the end one. In that case, you can see the region also. So here you can write that the transition is obtained in IR region. Or another clue that lies in your question is the paschen series. Paschen series lies in the IR region.